Okay, hello everybody. So today we're going to continue our discussion in Chapter 8, Section 1, and I'm going to show you how to add and subtract polynomials. Now, this is actually really similar to something that we have already done this year, which is using elimination to solve systems. It's very similar to that, although our goals are a little bit different. When we were using elimination to solve a system of equations, we were actually trying to get a variable to disappear or go away, to cancel out. And that's not really the goal here. The goal here is just to simplify the expression and get all the like terms together. So there's two different ways you can do this. I'm going to show you both ways in two separate videos. So the first way I'm going to show you is what is called the vertical method. And the vertical method allows us to kind of stack these two expressions up in a similar fashion like we did when we were solving systems using elimination. So here's what we're going to do. We're going to take these two polynomials that you see. The first one is 2x squared plus 5x minus 7. And we're going to add that to 3 minus 4x squared plus 6. Now, in order to add and subtract polynomials, the like terms need to be added and subtracted. But the way that we need to set this up is we want them both to be in standard form first to make this a lot easier. So that's what I'm going to go ahead and do. I'm going to put both of these in standard form. If you look at the first one, it's 2x squared plus 5x minus 7. That one's already in standard form. It starts with an x squared, it goes x to the first power, and then you have a minus 7, which is there's no power. The next one, though, is not in standard form. So we do need to reorder that one. And we're going to reorder it by writing negative 4x squared first, then writing 6x, then writing our positive 3. Now, you got to be careful with this. This minus right here goes with the 4, not with the 3. It is a positive 3. It's a positive 3 because there's nothing written there. That's why it says plus 3 down here. Okay, so now what we've done is we have stacked up our two polynomials to where you can see the columns line up with each other, and what you see in the columns are like terms. And so this had said we're supposed to add. And so what you see there is those two are to be added together because it has a plus in between them. So that's exactly what we're going to do here. We're going to add these two up. I have 2x squared minus or plus negative 4x squared, which is negative 2x squared. And then I have 5x plus 6x, which is 11x. And then I have negative 7 plus 3, which is negative 4. And so we end up getting our final answer by adding those two polynomials together. I get negative 2x squared plus 11x minus 4. This next one is going to be done in pretty much an identical fashion. We are going to go ahead and line them up vertically and then add them together because that's what they're asking us to do. If you look at this first polynomial, it is already in standard form. It starts with an x squared, then it goes to an x, and then it goes to a constant term. The second one is not, so I'm going to go ahead and put that in standard form, a negative 3x squared. And then we have a positive 6x, and finally a minus 3. So negative 3x squared was first, then we're listing a positive 6x, and then we're listing the minus 3, like that. Okay. Now, once we have the two polynomials stacked on each other, we're going to go ahead and add them up. So we're going to add just like that. And so 5x squared plus negative 3x squared is 2x squared. Negative 3x negative 3x plus 6x is going to be 3x, positive 3x. And then 4 plus negative 3 is positive 1. And so we ended up with 2x squared plus 3x plus 1. Now I'm going to skip this addition, this next one, because it's done exactly the same as the left. Now the next one I'm going to show you is going to be a polynomial that is a bit trickier than the last two. And here's why. If you look at the first one, you have a y to the fourth, and then it jumps directly to y to the first. So we're missing y to the third and y to the second. So that is going to be an issue whenever we try to add them up when you have y to the third right there. So here's what you need to do. If you are going to stack these up and do the vertical method, then you need to make sure that you leave spaces for any ones that you might be missing. And so in this case, we go from a y to the fourth to a y to the first. So I'm going to leave a space for y to the third right here. Now we don't have anything, I'm going to write it, but we also are going to leave a space for a y to the second because we don't have that. We do have minus 3y, and then we have plus 7. So I left a little bit of space there, and you're going to see why when I write the next one. The second one here is 2y to the third. That would go right here, 2y to the third. Okay. Then we have a 2y, which would go right underneath this one, plus 2y. So you can see that I'm lining up the variables that are like terms. We're matching them by their powers. So we've lined up 2y to the third and then positive 2y. The next one is negative 2y to the fourth. Well, that's going to go right here. And then the last one we're going to put is minus 11 right there. Okay. Now what you see is this has some gaps in here. There's a 0 right here, and there's a 0. That's okay. You can have zeros in there, but we're using those as placeholders. And the same goes for the second one. There is a 0 there where the y to the second would be, but there is no y to the second in either one of the algebraic expressions. So now we can go ahead and add them up. So we're going to add up both terms. So we have 1y to the fourth plus negative 2y to the fourth gives me negative y to the fourth. Then I have 0 plus 2y to the third. That gives me a positive 2y to the third. Then we have 0 plus 0, which is, of course, 0. And you don't need to write that in the end. We have negative 3y plus 2y. That's negative 1y. And then we have 7 plus negative 11, which is negative 4, just like that. And there's our final answer. Negative y to the fourth plus 2y to the third minus 1y minus 4. Now we're going to move on to subtracting. And subtracting is done in the exact same way if we do this using the vertical method, which is to line up your like terms and then subtract each one, just like we did whenever we learned the elimination method. So as in the last one, we need to have them in standard form. We need to have them written so all of their like terms are lining up in columns. So I'm going to do that. The first one would be 2x squared, and then minus 2x, and then plus 3. So 2x squared minus 2x, and then plus 3. The next term we're going to use is going to be the 3x squared. That's going to line up right here, 3x squared. Then we're going to have the 4x, it's a positive 4x, and then the minus 5, which is right there. So now that we've got all of the like terms lined up, we can simply subtract them, just like this. So 2x squared minus 3x squared is negative 1x squared. And then we have negative 2x minus 4x, which is negative 6x. And then we have 3 minus negative 5. That becomes 3 plus 5, which is 8. And there's your final answer. Here's another example of what we just did. This one is more similar, though, to the third addition problem that I showed you, where we are missing some terms that we have to make sure we account for whenever we line things up vertically. So if you look at the first one, we have an x to the third, then x to the second, then x to the first, and then we have a constant. And that's good. We have all four terms, 3, 2, 1, and then 0. But over here, we only have x to the third, and then we have x to the second. They skip x to the first, and then we just have minus 2. Okay, well, because they're skipping x to the first, we got to make sure we leave a space when we're lining things up. So let's write the first one. 4x to the third minus 3x squared plus 6x minus 4. And this second one, we're going to start with negative 2x to the third. Then we're going to have plus x squared, which is there. But then this minus 2 needs to be lined up underneath the minus 4. Now, since there's nothing here, I'm going to go ahead and just put a 0 in, just as a placeholder. I'm going to underline those. And now the whole bottom one is going to get subtracted, like that. Now, we're going to do 4x to the third minus negative 2x to the third. So minus negative becomes plus, and it's actually 6x to the third. Then we have negative 3x squared minus 1x squared, which becomes negative 4x squared. Then we have 6x minus 0, which is 6x. And then we have negative 4 minus negative 2. So that becomes negative 4 plus 2, which is negative 2. Negative 4 minus negative 2. This becomes negative 4 plus 2, which is negative 2. There is our final solution. 6x to the third minus 4x squared plus 6x minus 2. So the last one we're going to do is another subtraction. And as we did with the other ones, we need to get them in standard form and then get all their like terms to line up so we know where or what to subtract. So the first one has a 5y to the second. Then we have a positive 8y. And then we have a minus 10. So there's our first three terms from this one. The next three terms right here, the highest power we have is y, negative y to the third. Well, the first one didn't have a y to the third, so we have to have them in order. It's going to actually go over here. Then we're going to have the plus 12y. That's going to line up right underneath the 8 because those are like terms. And then we have a positive 7, which is going to line up right underneath the 10. So you can see this is going to be 0 right here. So there's nothing that goes in for the y squareds. Put your line and subtract. So up here we still have 0. So 0 minus negative 1 y to the third is just y to the third. Then we have 5y squared minus 0, which is 5y squared. And we have 8y minus 12y. That's negative 4y. And then we have negative 10 minus 7, which is negative 17. Like that. So we have y to the third plus 5y squared minus 4y minus 17. And there is your final answer. So I hope that made sense. This does take a little bit of practice to get used to. So if you have any questions, as always, send me an email and I'll be happy to help. Have a great day.